take out your notes. Today we're going to be looking at multiplying fractions. And in method 1 of adding and subtracting mixed numbers, method 1 was changing things to improper fractions. Okay? And you know how I said that most mathematicians like that method? The reason for that is it's the same method once we get to multiplying fractions. Well, one of the reasons. So in multiplying fractions, you are going to want to first rewrite all fractions as improper fractions. And that includes even whole numbers. Did you know that the whole number 3 can be written as 3 over 1? What's 3 divided by 1? Still 3. But we can write 3 as a fraction. And that's, in a sense, writing it as an improper fraction, because normally you would write just 3, but we can write it as a fraction. And so I have 3 over 1 times 3 over 4. Now, for multiplying, you multiply the tops with the tops and the bottoms with the bottoms. Now, that's not proper math terms. What should we call the tops? Numerators. And the bottoms? Denominators. But writing the word top is quicker than writing a numerator. So that might make it a little bit easier to learn. And then write your answer in lowest terms. So for your work now, for multiplying, 3 times 3, that's 9. 1 times 4, that's 4. And if you wanted to write that, you can leave your answer either as an improper fraction, or you could change this to a mixed fraction, which is 2 1/4. I'll accept either of those, unless sometimes I'll put in the question, write your final answer as a mixed fraction. Then you would have to change it to 2 1/4. No. No, the denominator won't always be 1. Let's see what this next one is. Skip that. Let's do this one. Okay. So we have 2 7ths times 7 over 4. So if you multiply across the top, 2 times 7, again, you could use your calculator for this if you needed to, 14. 7 times 4 is 28. But the last step in our instructions is that we always have to write our answer in lowest terms. Okay? So in lowest terms, yes, so Justin said, I can divide both of those by 2. That's 7 over 14. But we might not be done. Can we divide even more? I can divide them both by 7 over 14. I can divide both of those by 7. And that leaves me with 1/2. Now, for me, I always like to understand why something works. So I'm going to make up another example here. I'm going to do 3/4 times 2/3. Okay, we know the rule already, but I'm going to take, maybe our chocolate bar. On one edge, I'm going to split it into 4 sections. Would you agree that 3/4, if I just draw those dotted lines down, that 1, 2, 3 pieces would be 3/4? So if I shaded 3/4, I want to see if I've got a fancy, oh, I'm going to use a crayon. There we go. There's 1/4, there's 2/4, there's 3/4. Okay? Oh, first of all, what I'm about to do is connected to area. Have you guys done areas of rectangles before? Yes, you have, but maybe just a review. If I have a rectangle that's 2 by 5, what's the area? 10. And the reason is because this is split into 2, this is split into 5, and I have an area because there's going to be 10 units inside. Now, when you're doing an area, you just have to multiply 2 times 5. So if I wanted to do an area that was 3/4 times 2/3, well, this would represent 3/4. 2/3, I'll get my crayon out again. That would be 1/3. That would be 2/3. This would represent 2/3. If I wanted to find something that was 2/3 by 3/4, it would make this smaller rectangle. How many pieces are in that smaller rectangle? There's 6 pieces. 1, 2, 3, 4, 5, 6. How big are the pieces? If this is the whole rectangle, and this was split into quarters, and this was split into thirds, each piece is 1/12. So I have 6 pieces, and each piece is 1/12. My answer to this should be 6 out of 12. But now let's go through our rules. How do we multiply fractions? 3 times 2. 6. 4 times 3. Notice that the bottom numbers tell us how much it is in, how much or what the size of the pieces are. And then, of course, if you had 6 out of 12, that's the same as 1/2. That's why the rule for fractions is what it is. The bottom numbers multiplied together really tell you what size of pieces you're looking at. And the top numbers multiplied together tell you how many of those pieces you're going to have. Again, most people forget where it comes from, and they just go back to, oh, I'm supposed to remember these rules. But if you can understand where it comes from, it can help you remember it. So we multiply the tops with the tops and the bottoms with the bottoms. Here's another one with a whole number. 16 times 1/3. We need to change things to improper fractions. So I'm going to change 16 over 1 times 1 over 3. Multiply the tops with the tops, that's 16. Multiply the bottoms with the bottoms, that's 3. Or you could write this as 5 1/3. Is there a question at the back? No? Okay. Wake up, wake up. Maybe at the end, I'm going to give you a worksheet. You can work on them either at the boards or you can work on them at your desk. Okay? Everything okay back there? Yeah? All right. Sounds good. -7/3 times 6/5. When you have a fraction that is negative, you need to put that negative either with the top number or with the bottom number in your fraction. So I'm going to change -7/3 to -7/3 times 6/5. Again, here you could use your calculator, but every time, if you're going to go to your calculator, I want you to try mental math to say the answer first and then check it. 7 times 6. Close. -42. Then if you make a mistake in your times table, then take a moment to say, oh, okay, 7 times 6, 42. 7 times 6, 42. Right? Help yourself remember it. Because it's something like the more times you see something, the easier it is to remember. Okay? For example, on the very first day, at the beginning of class, I introduced myself. If you saw me in the hallway later that day, you might have go, oh, what's that teacher's name? You might have forgot. But now you've seen me every day, and you're like, oh, I wish I could forget his name, but you can't. Maybe that's the case. But the reason is you've seen me more often. So then it helps your memory. Same thing with multiplication. 7 times 6, 42. The more often you see it, the better you're going to remember it. 3 times 5, 15. Whew. And this is where sometimes things get a little tricky. You have to divide, see if there's a number that you can divide each one by. In this case, they can each divide by 3. 42 divided by 3 is 14. 15 divided by 3 is 5. Or you could write this as a mixed fraction, -2 4/5. I think personally that this is a hard step in this case. I think it's pretty hard to recognize that 42 and 15 are both divisible by 3, and it's hard to do that with mental math. So now I want to show you something you can do to make this question even easier. Okay, quick check. What's 7 times 6? 42. Now I'm gonna throw a curveball. What's 6 times 7? 42. And so if 7 times 6 and 6 times 7 are both 42, have I changed anything if I rewrite this like this? Is my answer going to change? No. But if I do that, can you see that there's one of those fractions you can simplify early? Right here, can you simplify 7/3 lower terms? No. 6/5 lower terms? No. But if I write it like this, can you simplify 6/3? What is it equal to? Close. The 2 would be on the top, right? This one simplifies to 2/1. Then if I multiply, look, 2 times -7. Oh, I get my -14. That much easier. 1 times 5, I get my 5. That much easier. So sometimes if we can simplify earlier, we can make our life easier. And as a math teacher, I'll give you another example. Okay? 7/13 times 13/5. Can you see that if you switch the top numbers around, you would have 13 times 7, keep the bottom ones the same. What is 13 divided by 13? 1. And then 1 times anything? There's our answer. So as a math teacher, or like when I'm doing these ones, I actually skip this step of rewriting them. And I'd go, oh, I know 13 divided by 13 is the same as 1 over 1. And then I remultiply. 7 times 1 is 7. 1 times 5 is 5. But those are some tricks that we can do to make it faster for us. But again, it takes practice. The more you practice, the more of, let's say, some of the shortcuts you understand, which makes the math even easier.